Area formulas. In this lesson, we'll explore the relationships among the area formulas for parallelograms, rectangles, triangles, and trapezoids. We're going to do this quickly, but at least you'll get the idea of how this works. Go on to page 1.2. Click the up triangle to show the dimension labels, base and height as opposed to length and width. Notice the color in here to emphasize area, amount of surface covered. Here it says we're going to look at the area of a parallelogram. So we have a rectangle and a parallelogram, the same base, same height. And as I pull this and change the base, both bases change. As I pull this point, the heights change. So we always have the same base and height. We know the formula for this one. We want to find it for this one. So the directions will say take point P and pull it to the right as far as you can. So I'll pull it to the right. And as you can see, a parallelogram really is a rectangle with the right triangle cut off and moved over. Next, we're going to look at the area of a triangle as opposed to a parallelogram. We just learned that this is base times height. Again, I can change the base and I can change the height, and they stay the same for both. To get the area formula for a triangle, grab point Q, pull it up and over. Two triangles make up the same area as a parallelogram. Each one of these is half base times height. Lastly, for a trapezoid, you see they have the same height. Other than that, there seems to be no connection. If I pull this point R up and over, these two trapezoids make up the same area of this parallelogram. Area of the parallelogram is base 1 plus base 2 times height. Each trapezoid would be half of that. So the students discover the formulas on their own. They see these videos playing in their heads to see why they're true. Very dynamic, very individually paced. End of video.